Okay, hey guys, so I am gonna just show you what I'd like you to do for today for PoE. Sorry, I'm being really quiet. I'm trying not to be too noisy over here at TSA State. So what I'm gonna ask you guys to do is first make a couple of predictions. So in your engineering notebooks, I want you guys to go ahead and title your notes. Just projectile motion simulation would be great. And then before you actually open up the simulation, I want you to write out these two questions here. So this one and this one. And I want you to write your answers in your notebooks. So I want you to think about if we were to continuously increase our launch angle, what is going to happen to things like horizontal range. So imagine horizontal range is how far this is going horizontally. We also want to think about how is that going to affect the height, the maximum height that it reaches to, its apex of the arc there. And then finally, time. So how is that going to affect the time aloft as well? And then I also want you to think about, as we increase the initial speed, what is going to happen? And again, specify range, height, and time. So again, you guys are writing your responses to this. This is a prediction. And actually, let's go ahead and write out predictions. Okay, so go ahead and write predictions for those two questions. Okay, next, I am going to ask you guys to make a copy of this document here. This is where it says make a copy of this Google Sheet. If you click that, it will take you to this document here. And that's where you're going to be recording your data. You can see I've already done one as an example. We're going to start by having that is the wrong thing to show you, sorry. Here we go. So the simulation is linked right here. And then, there we go. Hit play, intro. Go ahead and move that all the way down so that the height of your cannon is 0 meters, so it's on the ground. And then the initial launch angle is going to be 25 degrees, and our initial speed is going to be 15. We're going to leave that one alone. And then you're going to launch that, and then we can take this tool here, and we can see the total time it was in the air and the range in meters. And we can also move this over here and see the height, the maximum height. And you might notice that from here to here, the range should actually double and the time should also double. So our time up and our time down end up being the same. And like this distance to here, or to where the apex is, and then this distance, those should be the same distances. Okay, so then you're going to put that data in, and you can see I've entered that total time of flight, the range, and the maximum height here already. And then as you're going to go along, you're going to keep adding more data points. And eventually, you guys will have all your data in here, and it's going to show up and populate these. We're going to be creating a graph of that data. So let's just, in case any of you, I was going to make a worksheet and I changed my mind. It takes too much time. If you haven't made a graph in Google before, let me just show you real quick. So let's say that you've already gotten all of these tests done and you filled in all of these numbers. This column for range formula, you don't have to worry about that right now. I'll put a little gray on it so you don't worry about it right now. But once we have all of these filled in, we're going to do a graph. So I'm going to have you do insert. Oh, wait. we need to select our cells first. So what we're going to graph is speed versus, hold down your command key on your keyboard, and then total time of flight, then insert chart. And this isn't going to look great at the moment. We're going to change it to a scatter plot. And of course, there's only 1 point on it right now, so that's not a terribly exciting graph. But eventually, here we go. And usually it pulls in my title as well. I think it's a little, it's a little confused because it should be, oh, I'm sorry, we're not looking at initial speed yet. That would help if we picked the correct two. Get tired, sorry. Scatter plot, okay. There we go. And then over time, as you're increasing that angle up to 90 degrees, you should see a pattern happening there. And that is going to be your graph for launch angle versus time of flight. You might, if it doesn't automatically put in the title, let's see, customize. Axis and titles. So the title should be launch angle versus time of flight. Good. And then on the horizontal axis, that should be where we're putting the launch angle. And then vertical axis should be time of flight seconds. And that looks like it's popped up properly. So that's how we would create one of those graphs. And then if I'm going to do launch angle versus range, that's where now I have to hold down my command key and hit total range. So that way I'm selecting just these two, but not the one in the middle. And again, I held the command key so that this would stay selected, and it would also let me select this. Insert again, chart. It likes column chart, but that's probably just because the data kind of looks weird to use a scatter plot at this point. Okay, it's not liking that too much. Yeah, it might just not be liking that very much because we only have one data point here. If you have any trouble making those graphs, I'll help you out next week, okay? But I'd like you to do that for launch angle versus time of flight, as well as total range and maximum height, all versus the launch angle, because that's our independent variable, and then we're looking to see how these respond. Okay, secondly, then we're going to do, notice that we've got two tabs here, part 2, initial speed. So I'm going to have you guys set the launch angle to 45. And then I'm going to have you bring that speed all the way down to 3. And we are going to try that as well. You can zoom in if you need to get those values. Find that total time and the range, and also that apex. And fill in that data here. Again, please don't worry about range today. We will do the range formula next week. I haven't shown you guys the range formula yet. So you'll enter that data, and you're going to do the same thing, but this time with initial speed versus total time, initial speed versus total range, and initial speed versus maximum height. And you're going to put that data down here. Last thing that I want you to do is, under your graph, I want you to actually describe what happens, like in addition to having the graph right beneath, I want you guys to actually describe what happens. So as the launch angle increases, the time of flight And does it increase constantly? Is it always going up? Is it more like a quadratic where it increases at an increasing rate, or maybe it increases at a decreasing rate? Or do you not see a relationship? So I want you to be specific about that. And maybe it increases and then it decreases, or vice versa, but I want you to be specific about what you're seeing, and you're going to put that in this description underneath here, okay? You can't see my hands. Jeez, I'm sorry. But maybe it's quadratic, increasing at an increasing rate, or increasing at a decreasing rate, like the opposite, where it's curved but it's getting flatter, like that, as opposed to that. Or maybe it's just constant, or maybe you don't see a relationship. So I want you to be specific about that here. And so there should be a total of 3 graphs below here. I think if I look at my answer key, yeah. So this is what my answer key looks like. And then I have my descriptions down there. Obviously, I don't have data in here. I also did one that was total flight and total range, which I think I was... Yeah, no, I just did all of those. I think this one was some extra ones. So that should be everything that you need to do for those 2 documents. So part 1, we're looking at angle, and then part 2, we're looking at speed, and then we're going to just increase it by 3 each time. You can see 3, 6, 9, and so forth, and that's what we're going to be recording data in here. And so your final submission should have those 3 graphs on both of the I keep going to the wrong one, on both the initial speed and the angle one. So 3 total graphs on both of those. Okay, and then if you guys end up having any trouble with those, show me next week, Monday, and I can help you out with it, okay? All right, thanks guys, bye.